Computer animation, or CGI animation, is the process used for generating animated images by using computer graphics. The more general term computer-generated imagery encompasses both static scenes and dynamic images, while computer animation only refers to moving images. Modern computer animation usually uses 3D computer graphics, although 2D computer graphics are still used for stylistic, low bandwidth, and faster real-time renderings. Sometimes the target of the animation is the computer itself, but sometimes the target is another medium, such as film. Computer animation is essentially a digital successor to the stop-motion techniques used in traditional animation with 3D models and frame-by-frame animation of 2D illustrations. Computer-generated animations are more controllable than other more physically based processes, such as constructing miniatures for effects shots or hiring extras for crowd scenes, and because it allows the creation of images that would not be feasible using any other technology. It can also allow a single graphic artist to produce such content without the use of actors, expensive set pieces, or props. To create the illusion of movement, an image is displayed on the computer monitor and repeatedly replaced by a new image that is similar to it, but advanced slightly in time. This technique is identical to how the illusion of movement is achieved with television and motion pictures. For 3D animations, objects are built on the computer monitor and 3D figures are rigged with a virtual skeleton. For 2D figure animations, separate objects and separate transparent layers are used, with or without a virtual skeleton. Then the limbs, eyes, mouth, clothes, etc. of the figure are moved by the animator on keyframes. The differences in appearance between keyframes are automatically calculated by the computer in a process known as tweening or morphing. Finally, the animation is rendered. For 3D animations, all frames must be rendered after modeling is complete. For 2D vector animations, the rendering process is the keyframe illustration process, while tween frames are rendered as needed. For pre-recorded presentations, the rendered frames are transferred to a different format or medium such as film or digital video. The frames may also be rendered in real time as they are presented to the end-user audience. Low-bandwidth animations transmitted via the Internet often use software on the end-user's computer to render in real time as an alternative to streaming or pre-loaded high-bandwidth animations. A simple example. The screen is blank to a background color, such as red. Then, a goat is drawn on the screen. Next, the screen is blanked, but the goat is redrawn or duplicated slightly to the left of its original position. This process is repeated, each time moving the goat a bit to the left. If this process is repeated fast enough, the goat will appear to move smoothly to the left. This basic procedure is used for all moving pictures in films and television. The moving goat is an example of shifting the location of an object. More complex transformations of object properties such as size, shape, lighting effects often require calculations and computer rendering instead of simple redrawing or duplication. Explanation: to trick the eye and brain into thinking they are seeing a smoothly moving object, the pictures should be drawn at around 12 frames per second or faster. With rates above 75 to 120 frames s, no improvement in realism or smoothness is perceivable due to the way the eye and brain process images. At rates below 12 frames, most people can detect jerkiness associated with the drawing of new images, which detracts from the illusion of realistic movement. Conventional hand-drawn cartoon animation often uses 15 frames s in order to save on the number of drawings needed, but this is usually accepted because of the stylized nature of cartoons. Because it produces more realistic imagery, computer animation demands higher frame rates to reinforce this realism. Movie films seen in theaters in the United States runs at 24 frames per second, which is sufficient to create the illusion of continuous movement. For high resolution, adapters are used. History: early digital computer animation was developed at Bell Telephone Laboratories in the 1960s by Edward E. Zajac, Frank W. Sinden, Kenneth C. Knowlton, and A. Michael Knoll. Other digital animation was also practiced at the Lawrence Livermore National Laboratory. An early step in the history of computer animation was the sequel to the 1973 movie Westworld, a science fiction film about a society in which robots live and work among humans. The sequel, Future World, used 3D wireframe imagery which featured a computer-generated hand and face created by University of Utah graduates Edwin Catmull and Fred Park. This imagery had originally appeared in their student film A Computer-Animated Hand, which they completed in 1971. Developments in CGI technologies are reported each year at SIGGRAPH, an annual conference on computer graphics and interactive techniques which is attended each year by tens of thousands of computer professionals. Developers of computer games and 3D video cards strive to achieve the same visual quality on personal computers in real time as is possible for CGI films and animation. With rapid advancement of real-time rendering quality, artists began to use game engines to render non-interactive movies, leading to the art form machinima. The first feature-length computer-animated film was the 1995 movie Toy Story by Pixar. It followed an adventure centered around toys and their owners. The groundbreaking film was the first of many fully computer-animated films. Computer animation helped create blockbuster films such as Toy Story 3, Avatar, Shrek 2, Cars 2, Life of Pi, and Frozen. Methods of animating virtual characters. In most 3D computer animation systems, an animator creates a simplified representation of a character's anatomy, analogous to a skeleton or stick figure. The position of each segment of the skeletal model is defined by animation variables, or avars. In human and animal characters, many parts of the skeletal model correspond to actual bones, but skeletal animation is also used to animate other things, such as facial features. The character Woody in Toy Story, for example, uses 700 avars, including 100 avars in the face. The computer does not usually render the skeletal model directly, but uses the skeletal model to compute the exact position and orientation of the character, which is eventually rendered into an image. Thus, by changing the values of avars over time, the animator creates motion by making the character move from frame to frame. There are several methods for generating the avar values to obtain realistic motion. Traditionally, animators manipulate the avars directly. Rather than set avars for every frame, they usually set avars at strategic points in time and let the computer interpolate or tween between them, a process called keyframing. Keyframing puts control in the hands of the animator, and has roots in hand-drawn traditional animation. In contrast, a newer method called motion capture makes use of live action. When computer animation is driven by motion capture, a real performer acts out the scene as if they were the character to be animated. His or her motion is recorded to a computer using video cameras and markers, and the performance is then applied to the animated character. Each method has its advantages, and as of 2007, games and films are using either or both of these methods in productions. Keyframe animation can produce motions that would be difficult or impossible to act out, while motion capture can reproduce the subtleties of a particular actor. For example, in the 2006 film Pirates of the Caribbean, Dead Man's Chest, actor Bill Nighy provided the performance for the character Davy Jones. Even though Nighy himself doesn't appear in the film, the movie benefited from his performance by recording the nuances of his body language, posture, facial expressions, etc. Thus motion capture is appropriate in situations where believable, realistic behavior and action is required, but the types of characters required exceed what can be done through conventional costuming. Creating characters and objects on a computer. 3D computer animation combines 3D models of objects and programmed or hand keyframed movement. Models are constructed out of geometrical vertices, faces, and edges in a 3D coordinate system. Objects are sculpted much like real clay or plaster, working from general forms to specific details with various sculpting tools. Unless a 3D model is intended to be a solid color, it must be painted with textures for realism. A bone-joined animation system is set up to deform the CGI model. In a process called rigging, the virtual marionette is given various controllers and handles for controlling movement. Animation data can be created using motion capture, or keyframing by a human animator, or a combination of the two. 3D models rigged for animation may contain thousands of control points. For example, the character Woody in Pixar's movie Toy Story uses 700 specialized animation controllers. Rhythm and Hue Studios labored for 2 years to create Aslan in the movie The Chronicles of Narnia, The Lion, the Witch and the Wardrobe, which had about 1851 controllers, 742 in just the face alone. In the 2004 film The Day After Tomorrow, designers had to design forces of extreme weather with the help of video references and accurate meteorological facts. For the 2005 remake of King Kong, actor Andy Serkis was used to help designers pinpoint the gorilla's prime location in the shots and used his expressions to model human characteristics onto the creature. Serkis had earlier provided the voice and performance for Gollum in J.R.R. Tolkien's The Lord of the Rings trilogy. Computer animation development equipment. Computer animation can be created with a computer and animation software. Some impressive animation can be achieved even with basic programs. However, the rendering can take a lot of time on an ordinary home computer. Because of this, video game animators tend to use low-resolution, low-polygon count renders, such that the graphics can be rendered in real time on a home computer. Photorealistic animation would be impractical in this context. Professional animators of movies, television, and video sequences on computer games make photorealistic animation with high detail. This level of quality for movie animation would take tens to hundreds of years to create on a home computer. Many powerful workstation computers are used instead. Graphics workstation computers use 2 to 4 processors, and thus are a lot more powerful than a home computer, and are specialized for rendering. A large number of workstations are networked together to effectively act as a giant computer. The result is a computer-animated movie that can be completed in about 1 to 5 years. A workstation typically costs $2,000 to $16,000, with the more expensive stations being able to render much faster, due to the more technologically advanced hardware that they contain. Professionals also use digital movie cameras, motion capture or performance capture, blue screens, film editing software, props, and other tools for movie animation. Modeling human faces. The realistic modeling of human facial features is both one of the most challenging and sought-after elements in computer-generated imagery. Computer facial animation is a highly complex field where models typically include a very large number of animation variables. Historically speaking, the first SIGGRAPH tutorials on state-of-the-art in facial animation in 1989 and 1990 proved to be a turning point in the field by bringing together and consolidating multiple research elements, and sparked interest among a number of researchers. The facial action coding system, which had been developed in 1976, became a popular basis for many systems. As early as 2001, MPEG-4 included 68 face animation parameters for lips, jaws, etc., and the field has made significant progress since then, and the use of facial micro-expression has increased. In some cases, an effective space such as the PAD emotional state model can be used to assign specific emotions to the faces of avatars. In this approach, the PAD model is used as a high-level emotional space, and the lower-level space is the MPEG-4 facial animation parameters. A mid-level partial expression parameters space is then used to in a 2-level structure, the PAD PEP mapping and the PEP-FAP translation model. Realism in the future of computer animation. Realism in computer animation can mean making each frame look photorealistic, in the sense that the scene is rendered to resemble a photograph, or to making the animation of characters believable and lifelike. This article focuses on the second definition. Computer animation can be realistic with or without photorealistic rendering. One of the greatest challenges in computer animation has been creating human characters that look and move with the highest degree of realism. Many animated films instead feature characters that are anthropomorphic animals, machines, insects, fantasy creatures and characters, or humans with non-realistic, cartoon-like proportions. Part of the difficulty in making pleasing, realistic human characters is the uncanny valley, a concept where, up to a point, people have an increasingly negative emotional response as a human replica looks and acts more and more human. Also, some materials that commonly appear in a scene like cloth, foliage, fluids, and hair have proven more difficult to faithfully recreate and animate than others. Consequently, special software and techniques have been developed to better simulate these specific elements. In theory, realistic computer animation can reach a point where it is indistinguishable from real action captured on film. Where computer animation achieves this level of realism, it may have major repercussions for the film industry. The goal of computer animation is not always to emulate live action as closely as possible. Computer animation can also be tailored to mimic or substitute for other types of animation, such as traditional stop-motion animation. Some of the long-standing basic principles of animation, like squash and stretch, call for movement that is not strictly realistic, and such principles still see widespread application in computer animation. Media notable for realistic human characters: Final Fantasy, The Spirits Within, often cited as the first computer-generated movie to attempt to show realistic-looking humans. The Polar Express, Mars Needs Mums, L.A. Noire, received attention for its use of motion scan technology. The Adventures of Tintin, Heavy Rain, Beyond, Two Souls, Beowulf, movies. CGI short films have been produced as independent animation since 1976, although the popularity of computer animation skyrocketed during the modern era of U.S. animation. The first completely computer-generated television series was Reboot in 1994, and the first completely computer-generated animated movie was Toy Story. Notable computer animation studios: Pixar, notable for Toy Story, A Bug's Life, Monsters, Incorporated, Finding Nemo, The Incredibles, Cars, Ratatouille, Wall-E, Up, and Brave. Walt Disney Animation Studios, notable for Dinosaur, Chicken Little, Meet the Robinsons, Bolt, Tangled, Wreck-It Ralph, and Frozen. DreamWorks Animation, notable for Ants, Shrek, Madagascar, Kung Fu Panda, Monsters vs. Aliens, Megamind, How to Train Your Dragon, Rise of the Guardians: The Croods, and Turbo. Blue Sky Studios, notable for Ice Age, Robots, Horton Hears a Who, Rio, and Epic. Sony Pictures Animation, notable for Open Season, Surf's Up, Cloudy with a Chance of Meatballs, The Smurfs, and Hotel Transylvania. Illumination Entertainment, notable for Despicable Me, Hop, The Lorax, and Despicable Me 2. Alien Animation Studios, notable for Planet 51, Industrial Light and Magic, notable for Rango, notable for visual effects on live-action films like Star Wars and Pirates of the Caribbean. Weta Digital, notable for visual effect on live-action films like The Lord of the Rings film series, The Hobbit film series, and Avatar. Digital Domain, notable for visual effect on live-action films like Armageddon and Transformers: Dark of the Moon. Amateur Animation, the popularity of websites that allow members to upload their own movies for others to view has created a growing community of amateur computer animators. With utilities and programs often included free with modern operating systems, many users can make their own animated movies and shorts. Several free and open-source animation software applications exist as well. A popular amateur approach to animation is via the animated GIF format, which can be uploaded and seen on the web easily. Detailed examples and pseudocode. In 2D computer animation, moving objects are often referred to as a sprites. A sprite is an image that has a location associated with it. The location of the sprite is changed slightly, between each displayed frame, to make the sprite appear to move. The following pseudocode makes a sprite move from left to right. Varint x equals 0, y equals screen height /2. While x, screen width, draw background, draw sprite at x, y, draw on top of the background, x equals x plus 5, move to the right. Computer animation uses different techniques to produce animations. Most frequently, sophisticated mathematics is used to manipulate complex three-dimensional polygons, Apply a Euro-OE texturizer Euro, lighting and other effects to the polygons and finally rendering the complete image. A sophisticated graphical user interface may be used to create the animation and arrange its choreography. Another technique called constructive solid geometry defines objects by conducting Boolean operations on regular shapes, and has the advantage that animations may be accurately produced at any resolution. Let's step through the rendering of a simple image of a room with flatwood walls with a gray pyramid in the center of the room. The pyramid will have a spotlight shining on it. Each wall, the floor and the ceiling is a simple polygon, in this case, a rectangle. Each corner of the rectangles is defined by three values referred to as x, y and z. X is how far left and right the point is. Y is how far up and down the point is, and z is far in and out of the screen the point is. The wall nearest us would be defined by 4 points. Below is a representation of how the wall is defined. 0, 10, 0. 0, 0, 0. The far wall would be 0, 10, 20. 0, 0, 20. The pyramid is made up of 5 polygons, the rectangular base, and 4 triangular sides. To draw this image, the computer uses math to calculate how to project this image, defined by 3-dimensional data, onto a 2-dimensional computer screen. First, we must also define where our viewpoint is, that is, from what vantage point will the scene be drawn. Our viewpoint is inside the room a bit above the floor, directly in front of the pyramid. First, the computer will calculate which polygons are visible. The near wall will not be displayed at all, as it is behind our viewpoint. The far side of the pyramid will also not be drawn as it is hidden by the front of the pyramid. Next, each point is perspective projected onto the screen. The portions of the walls furthest to unregistered trademark from the viewpoint will appear to be shorter than the nearer areas due to perspective. To make the walls look like wood, a wood pattern, called a texture, will be drawn on them. To accomplish this, a technique called a Euro-OE texture mapping is often used. A small drawing of wood that can be repeatedly drawn in a matching tiled pattern is stretched and drawn onto the wall's final shape. The pyramid is solid gray, so its surfaces can just be rendered as gray. But we also have a spotlight. Where its light falls we lighten colors, where objects blocks the light we darken colors. Next we render the complete scene on the computer screen. If the numbers describing the position of the pyramid were changed and this process repeated, the pyramid would appear to move. Computer-assisted versus computer-generated animation. To animate means to give life to, and there are 2 basic ways that animators commonly do this. Computer-assisted animation is usually classed as 2-dimensional animation. Creators' drawings either hand-drawn or interactively drawn on the computer, using different assisting appliances and are positioned into specific software packages. Within the software package, the creator will place drawings into different keyframes which fundamentally create an outline of the most important movements. The computer will then fill in all the in-between frames, commonly known as tweening. Computer-assisted animation is basically using new technologies to cut down the time scale that traditional animation could take, but still having the elements of traditional drawings of characters or objects. 2 examples of films using computer-assisted animation are Beauty and the Beast and Ants. Computer-generated animation is known as 3-dimensional animation. Creators will design an object or character with an X, Y and Z axis. Unlike the traditional way of animation, no pencil-to-paper drawings create the way computer-generated animation works. The object or character created will then be taken into a software. Keyframing and tweening are also carried out in computer-generated animation, but are also a lot of techniques used that do not relate to traditional animation. Animators can break physical laws by using mathematical algorithms to cheat mass, force and gravity rulings. Fundamentally, time scale and quality could be said to be a preferred way to produce animation, as they are 2 major things that are enhanced by using computer-generated animation. Another great aspect of CGA is the fact you can create a flock of creatures to act independently when created as a group. An animal's fur can be programmed to wave in the wind and lie flat when it rains instead of programming each strand of hair separately. 3 examples of computer-generated animation movies are Toy Story, The Incredibles and Shrek. See also: animated images in Wikipedia, computer animation example, an animated pentakized dodecahedron, animation of an MRI brain scan, starting at the top of the head and moving towards the base. References: Masson, Terence. CG 101, a computer graphics industry reference. Digital Photography Incorporated PA 500. ISBN A0-7357-0046-XA.